So in this video, we're going to use the difference quotient with a linear function to find the equation of every secant line associated with that linear function. So here's the difference quotient from the previous video, and what we want to remember is that the difference quotient gives us a way to find the slope of any secant line through a graph of f of x. So in this example, it says use the difference quotient to find the slope of every arbitrary secant line associated with the function f of x equals 2x plus 1. So that's part A. Part B says then find the slope of the secant line that contains the points 1, 3, and 3, 7. So if we stop and think about this for a minute, the function f of x equals 2x plus 1. I have it graphed right over here. It's just a linear function. So if I pick two arbitrary points on that linear function, say 3, 7 and 1, 3, what we want to remember is that the secant line is just a line that passes through those 2 points. And if I pass a line through those 2 points, I see that I get just the line 2x plus 1 itself. So the slope of the secant line through those 2 points, if we do things correctly, should be the same as the slope of the line that contains those 2 points. So what we would expect to get is that the slope of the secant line through any 2 points on the graph of this linear function f of x is just going to be the slope of the line itself. So let's start off with part A, which tells us to find the slope of every arbitrary secant line associated with f of x. And to do that, we're going to use the difference quotient, which is sitting right here. So the difference quotient says do the function evaluated at x plus h minus the function evaluated at x, and then divide everything by h. So I'm going to go ahead and do that. So the first step in the numerator says evaluate the function. Here's my function, evaluated at f of x plus h. Okay. Minus, then evaluate the function at x. And then divide everything by h. And so what this is telling us to do is to look up at the function, and everywhere we see an x, replace the x with x plus h. So step 2 is f of x plus h is going to equal 2 times x plus 1, but we're replacing the x with x plus h, minus, and then it says just subtract off the function f of x. So the function f of x is just this stuff right here. F of x is 2x plus 1. So minus parentheses 2x plus 1, using a parenthesis so that the minus distributes into both terms. And then it says divide everything by h. And now simplify. So distribute the 2 into the parentheses. We get 2x plus 2h plus 1 minus 2x minus plus 1 is minus 1 all over h. And if we look at the numerator carefully, we get 2x minus 2x is 0. We have a 2h without any other h terms in the numerator, so plus 2h. And we get plus 1 minus 1 is plus 0. It's all over h. So the numerator simplifies to 2h over h. But as long as h isn't 0, h divided by h equals 1. So we get 2 times 1 is just 2, which is just the slope of the linear function. So the difference quotient, which gives us the slope of the secant line, is telling us that any 2 points you pick on the line f of x, when you calculate the slope of the secant line passing through them, you're just going to get the slope of the line itself. So I can, for part B then, find the slope of the secant line that contains those points. I can say the slope of the secant line through 1, 3 and 3, 7 is just 2.